Hey, so we're going to use interfaces in Java and Android to make our code cleaner and to be able to encapsulate logic from our program and be able to reuse it. So let's start with a little demo here. I have an icon that when I click it, oh my gosh, it gets bigger. When I click it again, it goes back to the same size. And there's a little switch up here which I can turn, and then when it's on and I click it, oh my gosh, it moves and then it moves back. Okay, so it moves. I click it down here. Oh, now it doesn't move. Now it's getting bigger and smaller. So you can see there are two different transformations. One transformation moves it back and forth. One transformation moves it larger and smaller. And these transformations are independent. Right, so when I move it over here, and then I do the other transform, it gets larger and smaller. Okay, so what you can see is there are two different transformations. Transform is the generic way of saying what we're doing, one of which is a translation or a move. I didn't use the word translation because it started with a T, and so did transform. So transform is the general, and we're either going to move or scale. Okay, so let's take a look at the code. First, the layout. The layout is pretty straightforward. We have two items, a switch and an image. So you don't have to worry too much about this, whatever, it's constraint layout. I just threw it together just to have something. So there isn't that much to learn there, but the point is there's a switch and there's an image button. And that's what we're going to transform. We're going to transform this image button based on the state of the switch. Okay. So in the code, we're going to have the switch, and we have to call it switch 1 because switch is a reserved word in Java. And then we're going to have a scale image view and a move image view. And scale and move image view are these other classes, and it implements this interface that we're going to talk about in a second. But let's just take a look at scale image view. Scale image view is very straightforward. It has one data item, a constructor that initializes that data item, and then it has this method called transform, and it takes in an image view, and in this case it scales the x value. So this is the one that is going to make it larger or smaller. Oh, sorry, it scales both values. It makes it larger or smaller. If it only scaled the x value, it wouldn't get bigger in the y direction. Move is kind of similar. It's also a very simple piece of code that really, it has a, separate this out, but it has a constructor, and then it just has this transform. And notice the signature, by which I mean the types for everything in this method. So it's public, it returns a void, takes in an image view, is the exact same as the transform method in scale image view. So these both have the exact same method type, and this does the same sort of thing. It just does this translation, and so this is just a simple way to animate a translation. It does the same thing here, image view.animate, and then this scale x and scale y. So this, if you're interested in animation, here's like a very simple way of doing it, and that can inform your project or inform your thinking about Android. So that's great. But what's going on here is both of these classes have this transform method. Okay, now let's look back at main activity. So main activity, before we even sort of get to the meat of the code, it defines an interface called transform image view. So we've got this image view, and we're going to transform it. Well, that looks familiar. Public, void, transform, and it takes an image view. Actually, I guess the public isn't needed. Yeah. It's got to be public for it to be in an interface. So main activity is saying, hey, I need something from an object. The thing I need is a public transform method. Well, this class defines this method, and so all the objects are going to implement this method. In Java, we have this keyword implements. So this is not extends. This is not inheritance. This is a more flexible form of, well, what is inheritance in C++ if you know that. But if you don't know that, this is just a way to specify some functionality and make sure that a given class or a given object that is an instance of that class implements that functionality. So this class is telling the compiler, hey, I implement the functionality from transform image view. So if I, do something here like take away this public, it's gonna bum out because it says, hey, this sort of, I thought this was going to be public and we don't have a public version of it, or whatever. If I just get rid of this and call this transform X, it's not going to build because it's going to say something along the lines of compilation failed. Move image view is not abstract and does not override abstract method transform. So you're telling me here that you're going to override the transform method. You don't, so you violated your agreement with me as the compiler. So we don't want to violate agreements in this course or ever as good people. So transform image view, if I implement this, I promise to give you a public void transform method. I'll get rid of the public because the compiler doesn't like it, so then I don't like it. Okay, so now, but see, here's sort of the trickaroo. What we say, this is sort of the concrete type, scale image view. This is an actual class, but here I have this, which looks like a reference to an object. This is, the type is transform image view. This is a reference to a transform image view, but transform image view is an interface. So that's weird. How can I get a reference to an interface? And the answer is you can't get a reference to an interface. You can only get a reference to an object. But if you get a reference to an object that implements your interface, that's cool. Like, as in, the compiler will accept that code and everything will work, which is sort of what you want. So let's take a look at what I mean by that. So on create, this stuff you should be getting familiar with. Call super on create, set content view, blah, blah, blah. This is some toolbar stuff. Whatever. That's also pretty basic. Okay, so first of all, I need to get a hold of my image button and assign it to my image view reference. Sure. And then I want to set this on click listener for the image view. And now here comes the trick. So whenever this image view is clicked, I am going to call transform image view dot transform and pass this image view. Okay, so what I'm saying is this click transforms. Now, I don't know necessarily how it's going to transform. It might scale, it might move, but this click transforms. Okay, and again, this is just some Java boilerplate in terms of what's going on there with the IDE, so you don't have to worry about that too much. It's just creating an embedded class, this new view.onClickListener. Okay, so I'm setting the onClickListener to something that is going to transform, and in the process, it's using this transform image view reference, which looks like a reference to an object as if it were an object, even though it's just an interface. Okay, so now here comes, the big reveal. Transform image view, depending on the state of the switch, this thing that looks like a reference to an interface, we're going to assign it a reference to an object that implements that interface. So that's why the compiler says this is fine. I have no problem with you doing it. This is of type move image view. This is of type scale image view, but both of them implement this interface, and so you can assign them to what looks like a reference to that interface. Okay, and this switch just, it just changes what transform is being done. Okay, I actually need to, initialize these. So here we're assigning these references. These references, maybe it'd be less confusing if I this isn't going to get executed before this, but maybe it'd be less confusing if I did this. Put these, initialize these up here. So we're going to initialize these references, and in the obvious way, just call the constructor, and then we're going to set up the switch, and the switch is going to assign this reference to an interface to one of these objects. Okay, and then here we just have a default, because this is a callback. This set on check change listener, that's just gets called back when you click the switch. That's the way you get from the UI to your code. So the callback says, hey, when somebody clicks that thing on the UI, will you actually call my code? Okay, so, and then this is going to look exactly the same as it did before. If your transform type is on, it's moving. If your transform type is off, it's scaling. And when I click this, it goes into this unchanged listener, and when I change the switch, it goes into this unchecked listener, and it changes this reference, transform image view. This reference is here. Anytime anytime I click the image, whatever this transform image view is pointing to, we call the transform method. So if it's pointing to the translate, then transform translates. If it's pointing to the scale, then transform scales. Okay? So you can use this pattern in your own code. When you want to implement some functionality, you can define an interface. Then you can define a class that implements that interface, and you can treat that interface like an object. You can get a reference to that interface, treat that as if it's a reference to an object, but then actually assign that reference to an object that implements that interface. Okay? If that's confusing, that's okay. I'm using the same words over and over again, but once you've programmed this once or twice, it's very natural, and you really get the point. It's just like, oh, okay. This is almost sort of like a partial object definition instead of a complete object definition. This is a complete object definition. I want to build one of these. Just give me a reference to it. But then here, I can actually take that reference and assign it to this reference to an interface, because this object implements this interface. Okay, so go forth and use this knowledge in your homeworks. If you like, it's not 100% required. We're just encouraging you to do it because you're going to see this pattern over and over again. Thank you.